Hey everyone, so I want to start this video series with a concept called recursion. So the reason I want to start with this is twofold. First of all, it's a little bit easier than some of the concepts we're going to follow in this course, so it's definitely a good starting point to kind of see what these videos are going to look like. Also, because when I was learning computer science, I hated this concept when I first saw it. So when I first saw it, I think I was a freshman in high school, and I hated this concept, okay, because I couldn't understand it. It drove me crazy. So when I first saw it, it was just like, what? I didn't understand how a function could call itself. It just didn't make sense to me. And then finally, my sophomore year, after about a year of struggling with it, I had a friend who came up to me and was like, hey, check this out. This is how you do it. And it was awesome. And he gave me some visuals. So that's partly the reason we're doing this whole video series, is because some of these concepts that we call easy computer science concepts, yeah, they are pretty simple and they're essential for really being a great computer scientist and particularly a great programmer. The only problem is you sometimes need the right visuals. So I'm going to do these videos to give you visuals, but also to see a computer scientist work through these problems. Okay, so some of these things I'm more seasoned on than others. Some of these things I haven't seen for years and I don't really use in my everyday practice. So I'm still going to work through them without rehearsing, without trying thousands of videos. I'm just going to jump right in and come up with some examples, and hopefully we'll make sense of this stuff together. So the idea is that I'm on here driving the content, but that you guys are in the descriptions. You're writing comments. You're adding to the discussion. So let's create a really cool space for these advanced computer science topics. So today we're talking about recursion. Okay, so while you're designing algorithms, and most of you know that an algorithm is just a series of steps that you write to complete some kind of problem, right, or to solve some kind of problem. And so while you're writing these algorithms, sometimes you'll get to this point where you're like, wow, like I feel like I'm repeating myself, or I feel like I need to, I want to put the algorithm or the function or the algorithm that I'm trying to create, I want to put it back into itself. Like I want to run it from here. And that's probably because you're running into a problem where you're going to need to use a recursive algorithm. Okay, so I'm going to talk to you about the two different parts of recursion, and I'm going to show you how to create a recursive algorithm for two very, very common mathematical operations: factorials and exponents. Okay. And they're a little bit different, but we're going to design them the exact same way. So first of all, let's talk about the two different. So we're going to sit down as computer scientists and we're going to design two recursive algorithms or two recursive functions using recursion. So here we go. So let's think about really quick the two parts of it. So every time you're going to be doing this, you're going to need something called a base. Okay, you're going to need the base case. Now let's say for now we're going to do factorials. So I think factorials are a little easier than exponents just because they only have one argument. So let's say factorials. Now factorial is like usually whenever you have like 5, and then the exponential part. So basically what you're saying is 5 times 4 times 3 times 2 times 1, right? That's a factorial. So as you can see, with each level that we decrease, we're doing the same thing, right? We're running the same function. We're doing basically what a factorial is really is n being the number that you put in, right? N times 5 minus 1, or sorry, n minus 1, then times n minus 2, then times n minus 3, as long as n is greater than 0, right? So what you're doing is just doing the same thing over and over. So we're going to mimic that by putting it inside of a function. Okay, so let's get rid of all this over here. And like I said, we're just going to assume we're doing factorial. Now, what is the base case of a factorial? So now that we have our thing that we want to write our recursive algorithm for, we got to figure out what's the base case. What's the case where when we put one, like let's say our program were to get to this point, we want it to be done. We want it to be complete, okay? It's the thing that if we put this into our function, we are getting one answer out. We don't want it to run anymore. And that would be when n, okay, so remember our argument, let's assume, let me put this, let's call it our function, and we'll just say it's fact, fact, okay? And then inside of our function, we're gonna say n. And n is our integer. That's the number that we want to do the factorial of, 5, 6, whatever. So our base case is going to be when we don't want it to do anything, and that's when n is 0, okay? So if, all right, so we're just gonna say base case is n equals 0. All right, and when n equals 0, we don't want our function to do anything else. So we have our base case, but now we need something called a recursive case. And did I cut off my R? No. All right, that's good. Recursive case. A recursive case is whenever we want our function to do something. Okay, we want our function to call itself, and I'm going to show you that in just a second. It sounds kind of weird, but whenever you see it, it kind of makes sense. So n is greater than 0. Okay, now in this case, we're doing you know, we're just staying with 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But other recursive functions, you may have something else, but usually it's going to be when n is greater than 0, okay? There are recursive functions where you count up, but most recursive functions, you start with the highest, you come down, especially with the two cases we're doing right now, okay? So we have our base case, we have our recursive case. Now, what you don't realize is you've just built your if-else statement, all right? You just built the if-else statement that you're going to use inside of your recursive function. So let's write some pseudocode, and let's, you know, figure out how we're going to write this, okay? So first, we need our function name. I'm going to kind of write it JavaScript style, Java style, but you know, you can kind of apply this to any programming language. So we're going to say fact, and we're going to say that we need an integer, and you don't have to declare the type of, you know, parameter in most programming languages, but we're going to do that anyway. So we're going to call it an integer, and we're going to say this integer is x. All right, and that's the number that we want to do. Okay, so let's say it's 5, or we'll talk about that. We're going to walk through it in just a second. Okay. So we jump right into our if statement, okay? Right into our if statement. Our if statement is going to be our base case, okay? We're just saying if x is equal to, so we'll do the, you know, we'll do comparisons, equal to 0. All right, we want to return 1. Return 1. All right, now if you don't know this, the factorial of 0 is 1. I don't understand why. If you do, put it in the chat box. I remember, like, or put it in the discussion board. I know that at one time, like, I learned it in math, but it doesn't make sense to me, but whatever. If you put 0 in there, the 0 factorial is 1. There's a whole mathematical explanation as to why, so please put it in the description. I'd love to see it. But I don't really care about it because it doesn't matter to me. All I know is that 0 is going to be 1, okay? Now, and we want it to be able to handle 1, okay? Because what if somebody puts 1 into our function, right? We want it to be able to handle 0. So this is kind of the lowest number that we want to be able to handle in our function. All right, so else is going to be if it's anything else, all right? If it's anything else. And we want to be able to handle all numbers from 1 to, you know, whatever, all right? The highest number that the programming language or the computer that we're using can handle, okay? So we wanted to be able to handle everything in one line of code, all right? And this is how we're going to do it. And this is where the first thing where it blew my mind when I was a freshman, but you'll get it, all right? So we're going to do return, because we want to return it. And a return statement is really, really important to recursion, okay? Because we have to keep having the same thing come back. This function has to create something, okay? So we're going to do x times, okay, now here's the crazy part. Here it is. Return x times fact. And that's the same function that we're creating, right? We're calling our own function inside of itself. Fact of x minus 1. Okay, now what are we doing? Why does this make any sense, okay? And you can see why it makes sense by just running through it. So let's run through this code as if, you know, we'll run through it to line by line. Let's put a number in. Let's put in the number 4, okay? So we want to find 4, okay? The factorial of 4. And we know that's 4 times 3 times 2 times 1, okay? Well, let's see what happens when we put it in this code. So we put in 4 here, okay? We put in 4 up here. And it goes and it checks if x is equal to 0. Well, it's not. It's not. It's 4. So we just go, we ignore that. We go right down to the else. Return, not return. Return 4. Okay, so let's go ahead and write that down. Let's return 4. So anytime you put return, you can assume that the program is kind of holding that value. It's returning that value, so you can write it down. You've created that value, okay? So we have 4 times, okay? Now we're multiplying that by the factorial of x minus 1. Well, x is 4. So x minus 1 is 3. So all we do is we take that 3, we go right back up to the top, and we put it back in the program. Okay, we already have our 4. This 4 stays down here, but we're putting it right back in our thing with our new value, okay, which is 3. So let's do it again. Is x 0? No, it's 3. So we go down to else. So we return x, which is 3. Here we go. It's now created. It's there. Times factorial of x minus 1. Well, now it's going to be 2. So we can still work with this, right? So let's go up 2. Here we go. All right, so we got 2. And we're going to do 2 again. Is it 0? No, it's not. Return x. So let's return our x times 2 minus 1, which is 1. So let's put it back up in there. Okay, there's 1 again. So is it 0? No, it's not. So return x times 1. Right? Return 1. Times factorial x minus 1. 1 minus 1 is 0, right? All right, and we've hit our base case. That's the point. That's what stops our program from running. If not, it would just run forever, but we haven't. We hit our base case. So now x is equal to 0. So we just return 1. So we add that to our return at the bottom. And what we get is the result of all of this. So the coolest part about recursion is it's kind of like you're breaking the problem up into really, really small pieces. And at the very end, you're just bringing it all together. So the result of our program is going to be 4 times 3 So 4 times 3 times 2 times 1 times 1, which is the factorial of 4. Okay, so we've done this, we've created this piece of code that has 5 lines of code. And in most programming languages, you're going to be able to do this in 5 lines of code. And all we have to do to run this function and then find the factorial on any number from 0 to whatever, we run the same function. We just call the same function and we just substitute x for whatever we want. So, and what's amazing about this is, think about it. The factorial for 4 takes how many steps? Well, you have to run this program 5 times, right? So roughly, let's just say it takes 5 full run-throughs of this program, okay? All right, that's not too many, whatever. We could probably write that sequentially. But what if you wanted the factorial of 1,000,000? Okay, first of all, it's probably going to be too big for your computer to handle, but let's say you wanted a factorial of 15 or 20. That's a real number, and that's something you might want to find, and you could run it in this function, and it doesn't take that much more time than if you just did the 4, right? And so it's pretty cool. It's a very efficient way to write algorithms. So let's work through one more example, and we're gonna do, this one's a little bit different, and the only reason it's different is because it has really like 2 arguments, but we're gonna design it and think of it in the same way, okay? So we're gonna do exponents, okay? Exponents. So we're gonna write a function called exp. It's gonna take an argument in, the same thing, it's gonna be an integer. But the difference is this one's going to take another one, and we'll call it x now. We'll just do x and y because sometimes it's, confusing. So we'll just do x and y. And I like doing x and y because whenever you start working with more advanced programs and stuff, you're going to be using like, matrices and stuff. And when you start using matrices, you start using xy coordinates. And so, for me, it works. A lot of programmers like to use n, some use I and j. It is, personal preference. All right, so we know what exponents are, right? We're going to do x raised to the y. That's what we want our program to do. Now, we could write a very, very simple sequential program for this, okay? You know that if you want to raise 5 to the 4, that's just saying 5 times 5 times 5 times 5, right? That's it. And that's recursion. You're doing the same thing over and over and over. But we can do this more efficiently, okay? We don't need to do that. We can do this more efficiently and to where we can substitute our arguments for anything and it work. So let's do our base real quick. Let's come up with our base. All right, so our base for exponents is pretty simple as well. Our base for exponents is, again, 0. If y is equal to 0, that's our base, all right? And so we know what we're going to get, our result will be out of that, but let's wait on that. But yeah, y is just going to be equal to 0, that's our base. And then we have recursive. Okay, in our recursive case is going to be y is greater than 0. Okay, now for these 2 examples, obviously our base and our recursive case are really simple, but we will dig deeper into this. Okay, this is the first video in this enrichment series. We're going to get so deep into recursion because recursion, you can do some extremely advanced algorithms with recursion. Some of the really most efficient sort algorithms, and particularly one algorithm, for example, where you find the greatest the greatest value summed array within a larger array is a really cool algorithm that we'll learn about later. We're going to do a whole video on that one. The base case and recursive case are a little bit more complicated, okay? So here we go. Let's do our thing. So let's call our exponent function. Let's name it. Let's take in 2, okay? Just x and y, okay? That is our base and our exponent, okay? And then we write our base if. All right, so our base is going to be y equals 0, all right? Because remember, like, and we'll do equals 2 equals 2. So if y is equal to 0, what are we returning? 1. Again, I don't know why. All right, just don't, again, put it in the description. I can't remember. I don't know why anything raised to the 0 is 1. Doesn't make sense to me because anything raised to the 0, you'd think it was either itself or I don't know. But it's 1, so we'll return 1. I don't know why. Return 1. And and I'm cheating a little bit because here's the deal. Returning 1 in our if statement really does help us with recursion. Okay, sometimes you have to do some really funky stuff in the if statement in the base case to make your value work. But in this case, both of these return 1 at the end, which is nice because then we just multiply it by 1 and we get our answer. So that's really nice. So I'm kind of cheating, but like I said, we'll talk about more difficult concepts later. Else, and now this is where we want to do what we want to do. Okay, so we want to return it because we want to create values just like we've been doing, right? That we have to return it. And then we want to return x. This is a little different. It's a little more funky to think about, but we're going to figure it out. X, okay, times exponent of x, y minus 1. I hope I didn't cut myself off. Oh, I didn't. Perfect. Okay, so this was a little bit different in that only one of the arguments, only one of our parameters is changing, right? Just x. X is the only one that's changing, and that it should be that way, because if you think about it, x is our base. X never changes. When you do exponents, your base never changes. You're just doing your base times itself as many times as the exponent tells you to. The exponent is what's decreasing every time, right? Because we know that when you do exponents, like, x to the y is the same as x to the y plus x to the y minus 1 plus x to the y minus 1 plus, and those are those situations you'll start to see, and that's when you know a recursion algorithm is probably better suited to do what you want to do. All right, so let's do this again. Let's put 4 to the 3 in there. Okay, 4 cubed. All right, so let's put 4 cubed in there and see what happens. Okay, so we have x is 4, y is 3. Okay, so y is not 0, so we go right down to else and we return 4. Okay, so yeah, check that out. All right, we're returning 4. And that's time exponent. So we're going to go exponent x, x stays the same, minus y minus 1, which now y is now 2. Okay, there you go. So we go back, we take y and we pull it back up here, and now we're saying 4 squared. We come on back down, we're going to get another 4. Okay, again, y is not 0, so we go to the recursive case. Recursive case in our else statement says that x, so we return our x, well, that's still 4, right? And times exp x, y minus 1, x stays the same, y is now 1, right back up in our program again. X stays the same, but y is 1, well, that's no longer a 2, that's a 1 now, right? So we do it again. Is y 0? No, it's 1. So we go down to else, return x, return another x. Whew, times. And the reason you know what symbol to use right here is going to be what symbol's right here. All right, so before you're decreasing, all right, your number that you want to use, that's the number that is going to go in between each of the values that you return, basically. Okay, so it's always going to be the same. And there are situations where you're going to be adding, or you're going to be adding to the x value. You're going to be, subtracting, dividing. Like I said, they're less common, but that does happen. So it just happens to be multiplication in both these cases because factorial and exponent are both multiplicative properties, right? So we do 4 times, and then we got another 4 because we came down, we got another 4. Now, however, it says 4 times exponent x, y minus 1. Well, y was 1, so now it's 0. So we take our 0, we put it back in there. Guess what? X is 4, y is now 0, so we hit our base case. Return 1, so we just do multiply times the 1. And we don't even really have to do this part. You don't have to. In this case, you really don't need the base case because it's just multiplying it by 1, so you really don't need it. But let's just assume it's there and we say times 1. I'm running out of spaces. Okay, so then all we have to do, we don't have to do this, right? I mean, we're doing it and we're walking through it because we want to, but we don't have to because the program's already done this for us. When you run this program, it adds all these up already, okay? It's returning this whole line of stuff, okay? So 4 times 4 is 16 times 4 is 64. Is that right? Yeah, okay, that was, my brain's kind of fried. So 64. So, all right. So 4 cubed is 64. I think, I hope, I don't know. Hope it is. But yeah, this is how you do it. So implementing this in code is really, really simple. No matter what programming language you want to use, this is basically how you're going to do it, as long as it is obviously like an object-oriented sequential type programming language. This is how you do it. So guys, if you have any questions about how to do recursion, or if you want to go over other examples, or if you want to add your own examples, all right. So not only is this enrichment for the students who want to learn more about these easy concepts, but it's also, enrichment in that if you want to expand for people, if you want to teach, this is a great way to do it. I've always said, if you want to remember something, teach it. That's the best way to do it. So put some examples in the chat box. If you want to see examples and you want me to work through something, I'll help you do it. If you want pseudocode for a recursion problem that you're looking at, let me know. We'll work through it. And also, if you have any ideas for any future episodes, I've got about 4 of them planned out, and we're going to get progressively harder each time. So if you have any ideas, something you want to see, something you don't understand about computer science, let me know and we'll make a video. So thank you guys so much for watching. I really appreciate it, and I'll see you in the next video. Bye.